Right, good morning. I just started the opinion survey. Please fill in those MC choice from question 3 to question 11. The one I just told you to do yesterday. Please do it now. Just put in a choice. Bồn Nhật Lộn, are you here? Bồn Nhật Lộn, are you here? Lý Kiên Lộc, are you here? Thẩm Quang Dậu, are you here? Lý Kiên Lộc, Thẩm Quang Dậu. Just make sure two of you, are you here? No, all right. So I check your options. 得14間填喎，幾多人咧？Now I'd like to check the work. Now, first of all, question 3. Okay. Now we will check the result as well. That is the results. Now, question 3. Question 3, the answer is A. Now, we are going to prepare copper to sulfate crystals. So, the combination of the copper and dilute sulfur acid. What I want is the part of them is from the base, the other one is the acid, right? The cation of the base, the anion of the acid. This is our common practice. So in this case, you may find the copper sulfate here, right? How about this? No reactions. How about this? No reactions. And how about this? Also no reaction. So the answer is A. Now, second is about question 4. Question 4. The answer is C. Now, all of you got it correct. It's magnesium nitrate. It's not the appropriate substance for preparing the magnesium sulfate by directly mixing it with the dilute sulfur acid. So if you use this one and get mix of the two, you may get magnesium sulfate. But at the same time, what you will get, it is nitric acid, right? So both, they are water soluble. Though they are water soluble, and it's quite hard to separate. So the answer should be C. Question 5. Question 5. Now the answer is somebody. Question 5. I can sense it. Many of you choose A. Okay, but the answer is C. What is the difference? A and C. Why not A? 有冇人答到啊？點解唔係 A 啊？
因為 barium sulfate 係呢個 insoluble。
Yeah. How about original substances? Barium carbonate, so as it is water insoluble. What will happen if I put this into dilute sulfur acid? So I put barium carbonate and put it into dilute sulfur acid to it. And what will happen is that a coating has been formed on the surface of the solid. So which will hinder the reaction. Okay. So we will call that a coating effect. Okay, so this is what A cannot do. How about C? For C, you are going to do a two-step synthesis. So first of all, if you are going to prepare barium sulfate, it is water insoluble. The first thing that you need to do is to prepare the two solutions. One containing barium ion, the other one sulfate ion to form barium sulfate. But of course, the starting material is not barium chloride, it is barium carbonate. So the very first step is to release the barium ion from barium carbonate to form the mobile barium ion, which is involved barium chloride. So that's why we have got two-step synthesis. The first step is to release the barium ion to form an aqueous solution. The second one is you may find it you are going to get mixed by precipitation. So do you find that this one? Please put so many stars here. It is the hybrid mode of the synthetic method. Okay, it's a hybrid mode of the synthetic method. So we have got to. Okay, is that clear? Now, question 6. Question 6. The answer is A. How many moles of nickel-2 nitrate sulfate crystal can be obtained? So you have to go back to the limiting reagent. So you may get to know how many moles of nickel-2 sulfate crystal can be formed. So this number of moles will determine the number of moles of nickel-2 sulfates to be formed. So it's simply a 1-to-1 mole ratio. So you have a multiplication, and you can get what I mean. Okay, so it is 50.0 times 10 to the power minus 3 dm cube. And this volume upon molarity is 2.00 mole per dm cube. So we may get it as 0.100 mole. So this is question 6. Is that clear? 有冇人問呢度？有冇人唔識做嘅？ How about question 7? Question 7. I found that many of you choose B, about 73%. Okay, question 3B, that is correct. 7B. Which of foreign pairs binds react together from PPT? Okay, this one. For carbonate, normally speaking, group 2 carbonate, that in generally it is not soluble in water. So as transition metal carbonate, and group 3 carbonate also. So do I want to make it more simple? You can. Most of them, they are insoluble in water. Insoluble in water, except what? Group 1 or ammonium carbonate. Can you get my point? Can you get my point? So this is what you may know about this. This is magnesium carbonate. This is water insoluble. So the answer is B. Question 8. Question 8. The answer is B. In experiments to prepare calcium sulfate excess, again you will see excess, right? This one is a limiting reagent. And first of all, you have to come up with the ionic equation to produce calcium sulfate. So this is 1.0, because it's calcium nitrate with the formula Ca bracket NO3. Okay, so you may simply do the multiplication, and you can get the number of moles, and use this to project the number of moles of calcium sulfate. Okay, and you are going to times the molar mass, and you can get the answer is 1.36 grams of calcium sulfate. Okay, is that clear? So I can see most of you have got it B. How about number 9? Number 9. What is that? It is a spraying function we call it scrubber, and some excited gas they will move upward. And what is liquid X? So you may see this one as an excited gas. You need to deal with the excited gas by using somewhat alkaline. A is a better choice. The answer is A. Question 10. Which of foreign pairs of the aqueous solution, when mixed, would give a precipitate? Okay, so aluminum nitrate and ammonia. Okay, you get mixed, you have got a precipitate of aluminum hydroxide. And copper sulfate, sodium nitrate, you may simply exchange the cation and double check if there is a precipitate. No, all those are water soluble. Similarly, for calcium, potassium, you exchange it to form potassium chloride, calcium nitrate, all those they are water soluble. So the answer is 8. Can you get the tricks? Okay, for choice B and choice number 2, choice number 3, what you need to do is to exchange one of the ion. Okay, so if you choose cation, you use cations at the start. If you do the same for anion, also is okay, but don't need to exchange cation and anion at the same time. Otherwise, the substance is still the same as the before. 11. Which of the following statements about HCl is all correct? The answer is A. Now, I would like to get some of your address of this. pH of HCl at any concentration is greater than 0. There can be the case, okay, there be the case that if the HCl with the molarity greater than 1 mole per dm cube, so the pH you may have a chance of having a negative value. Okay, it's not always greater than 0. It can be negative. So if you are going to deal with the acid, having a very high concentration. So this is the point number 1. Point number 3. How about number 1? Reaction with acid and alkaline is exothermic. No need to explain too much. Is the same one is correct. 2. Why not? Theoretically, you can get sodium chloride, but the reaction is too dangerous to perform. It will give you somewhat an explosion, right? Never react an acid, which is group 1 acid, to the group 1 metal, right? Group 1 metal and to the acid, and release explosion. Sodium and potassium you add to the acid are very explosive reaction. Is that clear? 有咩嘛？ Okay. This is what I come to this questions. Now, if not, we will come to the long questions today. 今日最主要做翻長題。So altogether, we have got several questions. I would like to get you some address to. If you flip the pages from 98 to 102, now you may see the questions being categorized into several groups. Can you generalize those questions? Now you may have some questions asking for the application, uses of neutralization, right? 有冇留意到啊？ So first of all, you may get some questions about uses and uses of neutralization. Okay, you may see some questions about qualitative analysis. So testing the unknown salt. So what is that? Okay, based on the precipitation reaction. And also you may get most of the questions on preparation salts. So among them, this one, it comprises most type of the questions when you talk about preparation of salts. Well, under this category, you may have got three methods. Now, which dealing with the nature of the solubility of the salt. So you may see the questions on long questions by having this category. Is that clear? Now, we start from some questions. 你見到呢度有幾種題目㗎，係咪？ So we start from preparation of salts， 比較簡單啲啦。Uses of neutralization 應該最簡單。So I'll give you some warm up here. A salt is formed when hydrogen ions they're replaced by metal ions or ammonium ion. The table below lists the chemical formula of the two acids. Deduce the chemical formula of all possible salts that can be formed when these two react. What will you get? Now, for those who know the answer, you may write it on the screen. I'll give you 3 minutes as a start. All potassium carbonate. Yeah. All possible, right? So yes, that's right. So I put this one as example. Right? It depends on the the number of moles of carbonic acid and the KOH, and it will lead to different answer. Now, for example, this one, it is carbonic acid. So what we'll get is K2CO3 plus what? If I having like this, K2CO3 and H2O, right? So this is the first answer, right, to be addressed. So this should be 2 here. How about KHO3, HCO3? How will you prepare this? In case alkaline is just 1 mole to 1 mole of carbonic acid. So you may have a case of having an acid salt. Okay, so how would you understand this? It's a matter of splitting of the two. So for the first case, the splitting will have this hydrogen ion and carbonic ion. The second one, how about this? How would you split that two? It is hydrogen ion and hydrogen carbonic ion. Okay, can you get my point? And I use the same trace I choose the metal part from a of a carbonate, and the acid, the other one is my alkaline, and you can get. What I mean is, if you want to make it a potassium carbonate, potassium ion, and carbonate ion should be chosen. Potassium hydrogen carbonate, which means this one is potassium ion, and hydrogen carbonate to be formed. And the way to make it as a difference depends on the amount of alkaline to be added. If I add 2 portions of alkaline to 1 portion of acid, but acid is diabasic, the salt is a normal salt. If I put that alkaline and acid in 1-to-1 mole ratio, the acid is acid salt. Do you understand? Now, similar case that you may find it on KOH and phosphoric acid, because phosphoric acid is a tribasic acid, right? You may separate the ions into this form. And the further separation will be this, and final separation will be this. So in other words, you may get the phosphoric acid to have a salt base, dihydrogen phosphate, and phosphates. And based on this, and you can get the salt form to be KH2PO4 if you are added just 1 mole of KOH. 2 mole of KOH added to 1 mole of acid, you may get a K2PHO4. And 3, the first one is K3PO4. Do you understand? It's for part B. How about part C? Magnesium oxide reacted phosphoric acid. Now you may use the same tricks, but this time I change from potassium ion to magnesium ion. So the ratio is a little bit different because magnesium ion carries negative +2 charge. It's different from potassium ion +1 charge. So the answer for this, we call it Mg bracket H2PO4 2, Mg HPO4, and Mg3 bracket PO4 2. Okay. Can I all follow? Understand? Now, so this is what I would like to share with you on this. Now, if time is allowed, I would like to share. I would like to ask you guys to do each type of question once. The first one is the preparation of water-soluble salt, but not group 2. You're going to ask the question. This is not group 2. Now, the similar questions that you may find it is question 13, 14, 15, 17. Okay. 11. Sorry, it's not 11, 21. 21. Just choose one of them. 13, 14, 15. 13, 14, 15. Choose 15, okay? 17. 21. Preparation of water-soluble salts. non-group 1. Okay, and please to question 15 now altogether. Okay, come up what I mean. Question 15. Copper to sulfate, this question, do you find it? Can be made by adding an excess of a solid copper to oxide to sulfuric acid, right? Dilute sulfuric acid is an exothermic reaction. Barnes equation is this complete ion equation, including stick symbol. Ionic equations. So what is it? Acid to form what? Copper to ion and H2O. Salt. Ionic equation. Question 2. Calculate the mass of copper oxide needed if 10% excess is required when 0.0020 mole of sulfuric acid is completely reacted. So according to the equations, so theoretically, number of moles of copper oxide needed is 0.020 mole. This is for theoretical. You need not handle that 10% for the time being. Firstly, so according to the equation, what equation? CuO plus H2SO4 to form CuSO4 plus H2O. The number of moles of copper oxide will be reacted to form H2SO4. It is 0.020 mole. Now, which is equal to the number of moles of H2SO4 according to this equation. So the mass of copper oxide reacted will be 0.020 mole time is molar mass. I don't want mole, I change it to gram. This is copper oxide, 79.5 gram per mole, 63.5 for copper, oxygen is 16. You add it together, 79.5. So here comes the answer. 1.59 gram. However, you are going to make it 10% more excess, right? So the mass of copper oxide needed, it is 10% more. It is 10% more. So you may get it as 1.75 gram. Okay? But of course, somebody may ask, right? What is the use of having it 10% more? Now, it depends on the practical sense. Now, for example, there may be some chemical loss during transfer of the chemicals, so you may need to make some more. So everything starts from the theoretical. Now, from the actual process, there may be some chemical loss. Okay, so that is one of the possible estimation to make the carbon dioxide slight excess, right? You are going to make sure that the sulfuric acid will all be reacted, but not too much. 10% is already a reasonable amount. B1, suggest with a reason how the copper oxide should be added to the boiling sulfuric acid. Can you see the word boiling? Boiling. So you ask for technique, suggest with a reason. So first of all, what will happen if I'm going to add some solid into boiling acid? So what will happen to the mixture? The mixture will boil over or splash, okay, or spill upon I add a boiling surfactant. Have you ever have a occasion of having nearly boiling water? I sprinkle it with a little salt. What will happen? Now the water will splash. So in order to prevent, you're going to prevent the mixture from boiling over, some splashing, some spilling. Can you get my point? So what should be done? What should be done? Any suggestions? 羅康力 Any suggestions? Some suggestions, right, to prevent the boiling over, the splash and the spilling of the. Any suggestions from Cameron students? 羅力喺咪度？
喺度喺度。
係啊，知唔知條問題問咩？
唔係好知。
Just like the case while you have a boiling water， 煲緊嘅水你滲啲鹽落去會點㗎？啲水會煲得好滾嘅。咁今次個 case 有啲似嘅。係啦，煲得冇咁滾。咁但係佢哋問題話，how 點樣加落去個 boiling acid 度？即係話嗰個 acid 已經係 boiling 喎。咁我要加落，點都要加啦。咁冇辦法中嘅辦法係點咧？你其實你嗰個方法最好嘅，即係唔好加咁熱啦。但係如果煲滾嗰時要你加，咁點加？加幾多啊份量？份量要加幾多？多啲定少啲好啲？
係咪少啲好啲？
即係少啲好啦，少啲佢會滾啦，但唔好滾得咁犀利啦。第二啦，除咗加少啲之外，你當你煮餸咁樣啦嚇，你明知加啲嘢，你會一瀡落去滾㗎嘛，仲要加少少，跟住之外會點啊？慢啲啦，加慢啲，冇加咁快啦。再咧，你會做啲咩㗎？做一個動作你會做嘅。
係咪攪佢啊？
係啊 ，with stirring，OK。所以呢度咧，其實有3個步驟已經出現咗啦。加少少，加好慢咁加少少，2步驟喎。第3攪，咁啊最好啦。你留意下，你平時煮餸都係㗎，屋企咧，如果啲嘢係滾嘅話咧，你再要滲啲固體落去嚟洗鹽嘅話咧，係有機會會煲再滾得勁啲嘅。嗱，普通滾水，譬如普通滾水，你滲糖滲鹽就會有呢個現象嘅。咁所以咧，一滲落去嗰陣時咧，第一較細啲火，好常見嘅；第二較細啲火咧，你不知不覺你都會去周去搞佢。OK， 因為 you're going to spread through those you're going to lessen the bubbling effect, not confined into a very small space. OK， 明唔明？好 B。When the reaction is complete, the excess carbon dioxide is removed by filtration. To prepare crystals of the carbon sulfate 5 water, the resulting solution is boiled to remove excess water. How would you know that when a sufficient water has been removed? 你點知道啲水已經煲到去 咩叫 excess water 先？你想令到個 solution 會點啊？你想整 crystal 嘛？係啦，要 saturator， 咁你點知你個 solution saturator？
用嗰個 glass wort 咯。
係啊，咁你又點講啊
？Dip a glass wort into the solution, then take it out and observe.
Yes.
If any solids form quickly on the surface of glass wort, the solution is saturated.
Yes, very good. Okay, so remember you are going to dip a glass rod， 又係寫翻嗰幾句啊 ，into the solution and take it out. And observe. If there is any crystal formed on the glass surface. If that is the case, the solution is saturated. If that is yes, right? After cooling the solution, the crystal form. State the color of the crystal. Blue, copper sulfate, 5 water. The crystal all have the same shape. What does it indicate about the arrangement of the ions? The ions, they are arranged in a very regular way, right? Very regular arrangement, okay? So every time the crystal produce, this is all that shape. What's that shape? 一個欖核咁樣嘅，咁樣嘅，即係尖尖地咁樣嘅。咁啱得佢黐黐得咁嘅樣，好得意。唔理大粒細粒都好靚，佢 crystal form 都係類似。OK， 有冇問？咁其餘嘅題目有類似嘅，所以我唔講啦。跟住咧就咁我哋就做23啦，23。Patience 呢個搞掂未先？23咧就係 preparation of salt 嘅問題，不過咧佢就轉咗做咩咧？佢轉咗做嗰個 case 係 uses of neutralization 啊。The patient suffer from stomach ache due to excess stomach acid. Okay, do you know stomach acid? HCl. So I use antacid tablet, aluminum hydroxide to deal with it. So you're going to write down the chemical equation for the reaction involved and answer the questions that follows. A. Write the chemical equation for the reaction between HCl and aluminum hydroxide. So what is that? Aluminum hydroxide react with HCl. So you may find somebody may find it hard to write down the balance equation, but don't worry, you may need to write down the salt form first. Half from the father, half from the mother. Aluminium ion and chloride ion. So you call it aluminium chloride. AlCl3. So once I write it like this, aluminium chloride, so you may see that 1 mole of aluminium here is 1. How about this? We've got 3 chlorine, so we should be putting it here as 3. Can you get a point? So that is you are heading towards the completion of the equations. Leaving behind is for water. How many for water? Now we've got 3 hydroxide here. Can you see? 3 hydroxide here. And 3 hydrogen here. So of course, the water should be in 3. It's solved. This is question 23. So this is the way to solve the questions. And then second, how does the pH of the grass juice change after the patient takes the tablets? What happens to the pH? The pH will be no change, increase or decrease. Question 8. What happened to the pH?
Should be rise.
Yes, should rise in pH, right? Increase. Why? The acidity of
佢揀
the
咗
plastic
啦。
juice decrease, right? So the pH value should be increased. 冇咁酸啊嘛 ，pH 值咪升。How about C? The plastic juice of a patient is found to be this. It produced to 黐線，好驚。我問埋啲咩問題嚟㗎？ Every day he produces 2 liter 2.0 dm cube of plastic juice each day. The molarity is 0.0450 molar HCl. This volume of plastic juice is treated with an anti-acid tablet containing 520 milligram of aluminum hydroxide per tablet. After taking a look on this, I must know what questions he's going to ask. They want to ask about what? How many tablets of the tablet is needed. I know the final. I know the final questions, right? So what should we do? Is to again do the calculations. But don't worry, you need to find out those. Everything starts from having this equation. And you're going to find a mass of aluminum hydroxide tablet, number of moles of HCl, and number of moles of aluminum hydroxide should be noted. So you see that it's 1 to 3 mole ratio. Okay, according to the equation. The number of moles of aluminum hydroxide tablet, which is equal to what? 1/3 of the number of moles of acid. Why is it 1/3? 1 portion of aluminum hydroxide, we react with 3 moles of HCl. So what we get? So number of moles of HCl, you can find it from the questions. 0.0500 mole per dm cube times its volume, 2.0 dm cube. So what we get is about 0.100 mole of acid originally. You divide it by 3 and you will get 0.0333 mole. 3 segment, right? So you calculate it as the mass of aluminum hydroxide needed will be 0.0333 mole times its molar mass. Its molar mass is 78.0 gram per mole. 78.0 gram per mole. So you get it as 2.60 gram. So that is part 1. C part of question 23. How about 2? Each tablet that would have 250 milligram. So how we change it to milligram to gram? Divided by 100. So the number of tablets needed. So check the unit very carefully. It's 2.60 grams as total, divided by each tablet weighs 250 milligram. So how you change it milligram to gram? Divided by 1,000 grams. Okay, you get my point. So it will be about how many tablets? Also exact the number 5. Can you get it? Can you get this one? Okay. So a very tricky question here. Now, last but not least, I would like to show you some questions about the qualitative analysis, which is question 20 and 24. Okay, 20 and 24. Oh, 25 is also preparation of salt. Okay, question 20 and 24. Qualitative analysis. It means the deduction of salt. What is that salt? What is the nature of salt? One for question 16 and question 22, it is the preparation of salts, but essay type question. So this is somewhat more challenging. Okay, this is somewhat more challenging. 16 and 22. So before we end up the lecture today, okay, I would like you guys to try it out one of them. Question 22. Outline the steps in preparing. 唔係喎，呢個做過呢條。啱啱 16未做過 ，22 做過啦，類似嘅嘢做過啦 ，16 呢個難啊，梗係難過22啦，知唔知難過22啲咩？22就做 precipitation reaction 咧，係咪？做過啦，咁第16咧 T44加啲未？呢個難啊 ，question 16 呢個難 ，essay type questions. Describe a lab method for preparing pure potassium sulfate crystal from potassium hydroxide solution and dilute superoxide. You'll be given this. So how do you prepare that?
Titration 我要用。
係啦 ，titration 啦，所以好長啊呢個 step。反而22咧易做好多啊，24咧就16嗰度就難做啲啊，因為咧要做 titration 係咪嘅？咁啊有冇第22做過㗎啦 ？So place the dilute sulfuric acid in a burette, and what's next? What is the next step? Using a pipette filler to replace. Oh yeah, so I can make it as a word pipette. 25.00 cm³ of dilute potassium hydroxide solution into a conical flask. And 3, add a few drops of indicator. What indicator is possible? It can be phenolphthalein. Ethyl orange is also acceptable in this case. Run the acid into the flask until phenolphthalein changes its color from pink to colorless. So record the results. And do the same thing. Procedure without, and then indicator. Okay? Without indicator, which means that run the same volume exit into the 25.0 cm chip of alkaline, but this time without indicator. Heat translate to evaporate the water and concentrate the potassium hydroxide solution, and then allow the concentrated potassium sulfate solution to cool at room temperature. Okay, to let crystal form. 跟住下一步做咩 ？Filter off the crystal. Filter off the crystal. Wash and dry 係咪 ？Wash the crystals with little cold distilled water. Dry the crystal between two pieces of filter paper。好，搞掂。因為咧佢呢度嗰個 source 咧係 potassium sulfate crystals 啊，所以咧亦都係 never put it into oven. Please do not put it into oven. Well, for question 22 is much simpler because it's just a mixing of the two solutions. You are going to heading for the preparation of silver. Let me check. This is silver chloride. If that is the case, you are going to have silver nitrate start. First of all, prepare it as a solution for silver nitrate and add any chloride solution, and you may form silver chloride. Filter it, wash the precipitate, and dry it. So you get even though we have given three methods, some of the procedures can be used interchangeably. Can you get a point? But some of them I use residue, some of them I use the spill shape. So it depends on the nature of the salt. If it's water soluble, if it's not water soluble, if it's a group 1 water soluble salt, or some other cases you use different method. Can you get a point? How do you feel about today's lecture? You get to know more about the whole procedure, right? Now, so this week I will ask you guys to have a quiz on chapter 14. Okay, question 14. Now today it's Tuesday. Can we manage to make it this Thursday to have this quiz? Well, next week we have the 2 quizzes. One for strength of acid, the other one is neutralization. Can you manage? Today, this week, it is unit quiz on unit 14 this Thursday. Can you manage to have it? Okay. Now you need to memorize quite a lot about the content. Okay. Any more questions? You need to memorize. Understand? If not, you see you guys. Bye bye.